All right, so yeah, I'm going to be talking about a really interesting site, Nighthawk Bison Jump in Caprock Canyon State Park. These are some of our partners. The Summerlee Foundation supported this work along with Texas Parks and Wildlife. This is in a Texas State Park. And Plains Archaeological Research here, they're a nonprofit organization that was created to do research on ranches throughout the Plains region, and they actually facilitated the funding of the work that we did because the Summerlee Foundation only gives money to nonprofit organizations. So they were really important in getting this work done. What you're looking at here, and this doesn't quite work, but what you're looking at here is the Nighthawk Bison Jump itself, looking to the southwest from a drone photo. And you can see it's a really rugged Badlands-like environment. All right, so if you don't know, the Caprock Canyon State Park, it's in Briscoe County in the Panhandle. It's a gem of a park. You gotta go. Nobody goes there. Everybody goes to Palo Duro. Go to Caprock Canyon State Park. You'll have it completely to yourself, except for the Texas bison herd, which roams freely within the park. So it's a really, really neat place. In a nutshell, this site, Nighthawk, it adds critical data to the story of Late Holocene bison hunting in the Southern Plains. This is what I was telling people at the beginning. Now we're at the point that the stuff we've discovered at this site, we're ready to sort of make a paradigm shift about the story of Southern Plains bison hunting, because there are things that we didn't think Southern Plains bison hunters did. And the Nighthawk site basically forced us to reconsider that. So, to start off with, what is a bison buffalo jump and why are they a big deal? First of all, I want to address the bison buffalo issue. What you have here on the left is a bison. What you have here on the right is a buffalo. Yeah. Now, if you don't make that distinction, some people don't understand what you're talking about. But this guy over here is a North American species. There are bison in Europe. They're called wiscent. They have an extra vertebrae and an extra rib. They're closely related, but different. They're 2.5 million years separation in their family lineage. This guy on the right is, the scientific name is Bubalus bubalus. That is a buffalo, okay? This is where we get our mozzarella from, okay? All mozzarella comes from that critter on the right. Nobody milks an American bison, okay? It's probably possible, but nobody does it. So I'm going to use the scientific word bison, the scientific name bison, throughout this presentation. One of the things that makes bison jumps exciting in all forms of mass bison hunting, that is, people killing bison in mass, is it's a communal activity. And anthropologists get excited about bison hunting as a communal activity because it implies so many other things happening within society that we can't usually see. Because killing large numbers of big, potentially violent animals requires a large number of people. The logistics involved, it implies you have multiple groups of people who probably throughout most of the year live in small bands of, say, 11 to 30 individuals, just basically family units. Those individuals are coming together in a family reunion-like situation and working together to dispatch large numbers of animals. And so this group coalescence is what makes bison jumps and all forms of mass bison hunting interesting, because there's all kinds of other things that happen. There's ceremonies, there's marriages, there's trade, there's all these other things that are happening at those camps that are base places for this communal hunting. And again, communal hunting happens all over the world. There are some good examples of people using large stone-lined structures in the Near East. They're called kites. They would hunt antelope using these fence structures. There's fence structures like that in South America. There are large reindeer drive lines that are now submerged beneath the Great Lakes that are over 10,000 years old in North America. So people have been hunting communally in these large military-like, configurations for a long time. So I wanted to get that out of the way before I jump into other stuff, because you have to use your imagination. These are large groups of people coming together in army-like battalions to get large numbers of animals all at one point in time. Okay, what is a bison jump? This is an illustration from 1962 from a symposium when bison jumping was all the rage. We were just figuring out what the prehistory, the pre-contact history of the Northern Plains was like, and people were going after these mass kill sites because they were really visible on the landscape. There are bison bone deposits at jumps and other types of sites in the Northern Plains that are so massive that people quarried them to make fertilizer out of the bones. So they're very apparent. And in any case, this illustration really shows, at that point in the 1960s, what we knew about bison jumps. And so you can see that there are several parts, and not all bison jumps have all of these parts to them, but essentially there's a grazing area, which is often called a collection basin. This is the place where the bison are drawn in, maybe because there's water, maybe because there's good grazing conditions. They're drawn into a particular point on the landscape, and if you're watching bison, right, and you're looking for herds of hundreds of animals, when they get to appropriate place on the landscape, you send out word to your neighbor, hey, the bison are here. Come over here. And then you have an assembly of people in position once the bison are in the right place, right? And so this grazing area or collection basin is the place from which people essentially draw the animals into what is called the drive lane. And a lot of sites in the Northern Plains have these features where there actually are carbs. Sometimes they're called dead men. There basically are lines of rocks, not necessarily walls that would pose any sort of barrier to the animals themselves, but lines of rocks that mark the edges of where people wanted to keep those bison, within the lines. And a lot of research has been done on these drive lanes in the Northern Plains where they actually believe, these stacks of rocks, in some cases, there are as few as 3. In some cases, they're up to 30. But they actually think that people would insert brush and things like that to essentially act as like scarecrows. So they would blow in the wind, right? So that's your drive lane. Your jump itself, right, which is a cliff of some sort where there would be a free fall. The deposit of bison bones, basically the place where the bison would hit the ground. And then you have your occupation site, which is the place where people are processing the animal remains after the hunt has occurred. So in a nutshell, those are the different parts of a bison jump, the classic bison jump, and we'll talk about some of those different parts at various points in this discussion. Bison jumps are jumps because the fall kills the bison. This is about maybe a 20-meter jump at Yellowstone, and there are road cuts all over the place in Yellowstone where bison do this all the time. There are probably like 6 different videos of bison doing exactly this. So there are other types of bison kill sites aside from jumps that we actually find in the Northern Plains where there are short jumps like this that wouldn't kill the animal, and they built pens around that lower surface. So essentially the bison would be dizzy and then stuck after they fell off the cliff like this. So that was an important distinction to make. And it just goes to show how tough these guys are, right? I mean, I didn't expect, when I first saw this video, I did not expect that animal to get up. And he just looks kind of embarrassed. Okay, so bison jumps they're important because they're dramatic and they draw our attention. It's a unique North American hunting technique. We do not see people driving animals in mass over cliffs anywhere else in the world with any regularity. Sometimes it happens, and when it does happen, it's not very well studied, but this is a unique North American thing. This is something that we can be proud of. Not only is it uniquely North American, it's unique to the Great Plains. And the pisgon, it's a Blackfoot word, describes basically the deposit that's left behind after this, mass murder of animals, and it translates to kettle of blood. And so the word pisgon has been applied to all forms of mass bison killing sites. In some cases, there are jumps. In other cases, there are arroyo traps, because there are lots of different ways to kill large numbers of bison all in one fell swoop. Throwing them, getting them to run off a cliff where they will be killed from the fall is one way. Another way is what's called a trap, sometimes an arroyo trap, where you herd them into a narrow gully with a cut face wall where they essentially would be stuck. The thing that makes bison jumps unique is you don't have to throw a spear or shoot an arrow to make it happen. Okay, all the other methods you have to actively kill the bison. With the deadfall technique, getting them to run off a cliff like this, maybe you have to club a couple ones that didn't quite die when they hit the ground. But the result of this is we don't find a lot of projectile points at bison jump sites. The proportions of projectile points to bison is very low. So I'm going to show you some projectile points, some arrowheads, but there aren't going to be very many at this site. The other thing that makes bison jumps really interesting is it's this massive windfall of food and materials. Jack Brink, who studied the important World Heritage Site Head Smashed in Alberta, Canada, likes to say that it's the most productive food-getting event in human history, period. The amount of food and material generated by a single event in a single moment, it's more food than if you were to go and kill a blue whale. Okay? Wow. And it's just numbers. So here's some numbers that people have crunched. The average communal bison hunting event yielded over 260 million calories in a single moment in time. That's enough to meet the daily energy needs of 100 adult foragers for 2 years. Wow. And doing this collectively as a group has fewer costs, it reduces the risk of failure, and it produces a staggering rewards. And so for comparison, killing an average of about 100 bison in one particular event, right? And this is figured to be average from ethnohistorical sources and actual bone number counts at archaeological sites, as compared to killing an elephant or killing a large number of caribou. You can see the distance between these things. And so people realized that in the plains, and they made use of it. The other thing that's exciting about bison jumps, especially in Texas, is they're super rare. People have long thought, this is why it's sort of a paradigm shift, that jumps are basically non-existent in the southern plains. And there's this strong false perception that jumps were the standard procedure everywhere. Yes, people hunted bison in Texas. People hunted them in pre-contact period, they hunted them in the historic period. They did not hunt them in large numbers, okay? We have one bison bone from the Crying Woman site. In most other archaic age sites in Texas and central Texas, there'll be a minimum of, say, 4 individual bison over a time span of 3,000 years. A lot of these sites are time averaged to about 3,000 years or so. So we don't have examples of people killing large numbers of bison all at once. We don't have mass kill sites. Up until the discovery of Caprock, in Caprock Canyon, the only other site we had here in the Southern Plains was Bonfire Shelter. How many people are familiar with Bonfire Shelter? Great. Okay. Well, if you're not familiar with Bonfire Shelter, it's, number one, the oldest bison jump in the world. It was the only bison jump in Texas, period. There are 2 components. to bonfire. One is Paleo-Indian, one is late Archaic age. And for a long time, because it's the most southerly and the oldest bison jump known, people thought it was fake. Not fake archaeology-wise, but they thought it wasn't necessarily a jump. And archaeologists came up with all of these alternative explanations to explain away the pattern here. And this is actually a publication from 2007 by people from Southern Methodist University who actually looked at the bones from Bonfire Shelter. They looked at the distribution of these bison jump sites that are known in the northern plains. You can see how dense it is up there. And they said, this thing can't possibly be real, right? Seems reasonable. So here's the density of bison jump sites in the northern plains. This is Montana and Alberta. There are so many up there that we don't even have a really good accounting of what's there. A lot of them have been claimed, but a lot haven't received the level of scientific scrutiny that you would get, say, in Texas, because bison jumps aren't supposed to be here. The other great thing about working in Caprock Canyon State Park at the Nighthawk site is we have this resident descendant community. This is the Texas State Herd, which is the remnant population that Charles Goodnight and his wife saved in the late 1800s from a group of 8 or 12 bison. And so genetically, this is a distinct lineage. Their DNA has been analyzed by conservation geneticists at the Texas A&M University. They have a distinct mitochondrial genome. We don't know how far back in time it goes, but we now have DNA from the Nighthawk site that may shed some light on this. They are interesting because Southern Plains bison are said in the historic record, and as you can see today, they are smaller than Northern Plains bison. Bison are a subarctic critter. They like to live up near Canada. And these guys got as far down as Mexico in the past. These guys, you can see, this one kind of has a reddish tinge to his coat. That's a calf. This one's brown. That's weird. That's a genetic abnormality. Okay, so this group, the conservation geneticists have been looking at the Texas herd for a long time because they've had a lot of genetic abnormalities and the infant fatality was pretty high. So they've actually introduced new genes, studs, into the herd to try to increase their diversity over time, which is just an interesting thing. But anyways, having that herd there while we're working on dead bison from this bison jump, I tell people it's like digging up dinosaur bones at Jurassic Park. So it's a really exciting, unique situation to have those descendants potentially looking over your work. The other neat thing about having the bison right nearby in the park is we can look at what happens to their bodies after they die on the very same landscape where we're trying to understand what happened to these bones after they were deposited here. And so we can develop good analogies, experimental models to see how bones shift around and get disturbed by things that potentially aren't what we're looking for in terms of human evidence, right? We're trying to get at what is the human element here. So here's an example where bison had died, and we went out with pin flags and mapped where all those bones came from and how they got dispersed by coyotes. And it was a pretty incredible thing. The coyotes have moved those bones the length of like a football field in less than a year. So you can imagine you have this massive bone bed with hundreds of animals laying around beneath a cliff somewhere. Those bones are going to get moved around in unexpected ways. So this was illuminating. The other thing we did was we were actually able to butcher a bison bull that had died of natural causes with stone tools that were collected from nearby, and got a good sense of how freaking hard it is. I happened to be wearing like a little fitness tracker, and in 3 hours I burned 1,500 calories doing this bison butchery. So to give you guys a little sense of the timeline of this work, Rick and Susan Day, they are Texas Historical Commission stewards, found the site in November of 2021. Rick gave Dr. Chris Lintz a call, said, hey, I found this interesting thing, come out and take a look at it. And Chris went out there with Rick and Andy Bertram, and Chris wrote up a really nice summary of that trip and sent it over to the Texas Parks and Wildlife to impress upon them the importance of this find. And that precipitated a bunch of other stuff. So Texas Parks and Wildlife, they don't have a lot of funds to do, big block excavations. So they had the idea of working with Texas Tech University, in particular Dr. Brett Hauk and Dr. Tamara Walter, to run a field school at this site to test it, right? Let's get some data. Let's not have to spend money to get the data on this site. And so that happened in 2022, 2023. I went out on a field trip with my mentor, Dr. Charles Frederick, at one point. And I live in Houston. I mostly work in the Southeast. I thought this was too cool. I volunteered my time to work on this. I said, I want to study those bison bones. Nobody else here knows anything about bison bones, so I'm going to do it. So I got involved. And I was like, well, we need to dig more because Texas Tech only dug, maybe 5 cubes, 5 1x1 meter cubes. It wasn't much. And they didn't send the students in places that were potentially dangerous in terms of where you're standing, because it's a really rugged landscape. So we need to go at this again. So I was actually able to go get money from the Summerlee Foundation to fund additional salvage excavations. Around the same time, we nominated the site to the State Archeological Landmark status, so it's super well protected now. And then we went back and did salvage field work in the spring of 2024. And as of last year, we finished the government report. We now have a paper in press with American Antiquity that is we're disseminating this. It's a big deal. So we're at the end of our work now. That's a really rapid turnaround for a bison jump site. You have hundreds of animals, right? So we dug it up, I analyzed it all within 2 years or so good for me. Tell people, just wanted to impress upon people how hard it was to do all of this. Here's a view of our field work in spring. That's the jump off surface there. It's about a 20-meter fall from that surface. This is just to show how much better our site is than all other bison kills in the area. There are a few other mass bison kill sites in the region. They are not jumps. They are arroyo traps, right? There are maybe 6 or so. And just in terms of area excavated, those 1x1 meter cubes, we've got more than 90% of the record in terms of what's been excavated. So we've learned a lot from this site, and there's still deposit there that we weren't able to actually excavate. This was a salvage excavation. We went in, got what we could, and now we're letting nature take its course. Here's another view of the excavations.
Wow.
And you can see, it's very steep. We had to essentially engineer ways to get up and down and to, have stable working surfaces. And the erosion is such that a lot of these deposits were halved. There was very little left. This entire hillside is just half of what the deposit of what would have been there in the past. And so, where it was, nice. Yeah, this whole thing is one layer of bone at the base of this deposit. All right, so at the point at which we finished our work in 2024, well, what do we know? We had a jump complex with two different areas. There's the site over here on the right, and then this site, and then there's a space in between where we didn't find anything, right? We knew that there was serious erosion. We had bone beds separated in pockets. That's what all these little stars are supposed to symbolize. And they're not commonly stratified, right? We don't have like one layer on top of another layer with bone. There are very few places where it was like that. A lot of stone tools were laying around on this surface, which was deflated. It's just a deflated surface. But what was obvious from the very beginning was that this was a jump, because bison cannot climb up to this surface today. The only way that bison can get there is by falling from above. So that was really important. Early on we had some rangefinder radiocarbon dates that were done, and our initial results showed that we had two events separated by about 1,000 years. One was a late archaic component that goes with this Marcos style corner notched dark point, and then a late prehistoric component which goes with this smaller Washita arrow point. This is just another photo showing where the distribution of the different bone bed deposits were, and the red squares are fire-cracked rock, burnt rock, some of the projectile points here. So, problem that at that point in which I was trying to interpret this, we had 12 distinct areas that had bone. They weren't stratified. The red dirt, the deposits all look the same. So how do we make sense of this? Luckily, we had a really healthy budget to do a lot of radiocarbon dating directly on the bison remains themselves. And this is something that wasn't done for most of those bison jumps that were excavated in the 1970s, because you couldn't date bone directly back then. Well, you could, but you had to have a huge amount of it. Now we can date collagen directly from the bone in relatively small amounts. So, and the other neat thing about what we were able to do here was, you'll notice there's scoring on this molar. We did serial isotope sampling to look at the chemistry of the diet of these different individuals through their lifespan. So we got a date, we got the chemistry of their lifespan, and now we have DNA on these individuals, which is really cool. Okay, so here are the results of some 30 radiocarbon dates that we're able to get, and you actually start to see a pattern here. You have a cluster of dates right here, which we call kill 1. This is not statistically one event, it's actually two different events. Kill 2 is one event. Kill 3 right here, which is the largest sample that we have from the site. That also is technically two events. So, I say we have 7 kills in 3,000 years at Nighthawk. It's a minimum of 7 kills. It's more like 9 or 10. And that doesn't include all of the bones that we weren't able to date or that didn't preserve. So the take-home point is this bison jump was used for a really long time, and that's something that we don't have at most other bison jumps. We have jumps where there's one deposit, it was used once, maybe for a relatively short period of time. There are maybe 4 other jump sites like this in North America. So, very interesting. That's, basically pie chart showing, kill 3 is big, everything else is relatively small. Kill 7 is only represented by a single individual. So I'm going to go through each one of these kill events and paint a picture here. Kill 1 and 2 are furthest away from where the cliff is today. Interesting clue. Okay, so kill 1 is about 3,500 calibrated years before present. And we had bone remains over here in what we originally called the processing site, because we thought they were killing animals here and dragging their bones over here to process. There was a lot of processing debris, burned rock, that kind of stuff over here. And the cliff is way over there, so we figured it's probably a processing area. We changed our minds. So kill one. Here's an example of some of the things we found. There were a minimum of 4 individuals, about 250 elements that we could identify, 3 skulls, 3 mandibles. A 1.5-year-old was represented, as well as a 8.5-year-old. And so that suggested, essentially, based on that age structure of that group, that this kill probably occurred in the fall, because that's what the composition of a bison herd that is killed in the fall looks like. We can tell that based on the fact that bison are born in a certain season, their teeth develop in a predictable way, and the teeth that we found there were consistent with that. We found 4 limbs that were stacked in a way that suggested it could have been some kind of assembly line with people cutting up bison, setting them aside. There were cut marks on those bones. Here's a photo micrograph of a mandible with cut marks on it that came from this area. We also had canid puncture marks on some of the bones. So this was a wolf that somebody found while they were hiking in the park. We radiocarbon dated that. It turned out to be about 1600 AD, a couple hundred years old, this wolf, which was pretty cool. This wasn't at the site. This was somewhere else in the park. But you can see that its teeth fit almost perfectly in these puncture marks on this long bone here. This is part of a pelvis. So were these wolf scavengers that came in and chewed on the bones after people left the site, or was this somebody's dog that was there? We don't know. The other interesting thing is the toe bones of one of these limbs that was stacked in this particular area have these curvilinear fractures. It looks like somebody just chopped at it with a trowel, but it's not cut marks. These curvilinear fractures go around the edges of the bone in a regular way, and we see this often with cremated human remains. What happens is when fleshy remains are thrown into hot fires, the periosteum covering the bone itself actually pulls the bone apart and creates these funky fractures. So the toes of this bison limb were sticking in a fire. I don't know what that means, but it was interesting to see that. So that's kill one. And, I originally said that we thought this was initially a processing site. We decided that it couldn't be because we had almost entire bodies of bison. And from where the cliff is to here today, it's almost the length of a football field. You don't drag a 1-ton animal the length of a football field without cutting it up. Okay? So somehow the bison arrived here intact. And originally I had this wacky idea that, maybe some bison bounced off of the pile of other dead bison and were relatively uninjured and then somehow limped over here and then people killed it. That's not what happened. We'll get to that. All right, so kill 2 is actually stratified above kill 1. Yay, we actually are able to figure out time ordering here. Kill 2 is about 3,000 years old, consists of just a few bones. We didn't really find much there. And then this red star over here is actually a hearth, which I'm showing right here in the upper right-hand corner. We found this after we had finished excavating. I was out there trying to do geoarchaeology, doing profiling of our excavations once all of the diggers were out. And this thing just appeared one day because it had rained a lot and we could actually see it. And so this is a possibly stone-lined hearth. It's a hearth that's got stone in it, right? And we were able to get juniper charcoal out of that, and it dates to exactly the same time as those bison remains from that other area. So this is showing one of the side cuts in this colluvial slope deposit at that particular site. So you've got the kill 1 bone down here, kill 2 bone up here. And there may actually be another kill event up here that we didn't date. So, all right. That's kill 1 and kill 2. Now, 1,000 years later, kill 3, which is the biggest sample that we have at the Nighthawk site. How do we get from all of the bison bones being here to all the bison bones being there? The cliff itself disappeared. So the jump off location for kill 1 and kill 2 was right here. The cliff itself got cut off and slowly worked its way down, eroded down over the years, and then the subsequent jump off position was right here. So it used to be there was a ramp that extended all the way out, like a little peninsula. And you can see the vestige of it right here. See that? So in 1,300 years, the jump off shifted almost 200 meters. The erosion in this landscape is astonishing. And to give you a little analog, this is how erosion works in the Panhandle. Everybody who has been to Palo Duro State Park knows about the lighthouse, right? So imagine this. All right, there's our continuous surface from where the jump off is today. So the whole platform didn't have to disappear. All that needed to happen was for it to get cut off like this, right? And then the jump off position would have shifted completely, right? So it's like, yeah, there's been a lot of erosion, but not that much needed to happen for the jump off location to shift way over to the west. And heterolithic bedrock erosion, basically what that means is you have these bedrock deposits that are alternating layers of tough and not so tough dirt, right? And that's the style of erosion that you find in this part of Texas. That's important because you don't get gradual slopes. So there's no way ever that bison would have been able to walk up a ramp. And that's one of the things that you have to have in communal bison hunting is you have to be able to drive those bison in a manner that is unobstructed, right? You can't drive bison to an arroyo head cut if they have to deal with all kinds of obstacles. It's yet another reason that this site is a jump. Okay, I'm paranoid about people questioning whether it's a jump or not because there aren't very many of them, right? So I have to make a really strong scientific case for that. This heterolithic bedrock erosion thing is an important key to that. All right, so moving on to kill 3, there's so much that we can't even talk about it. 17 individuals, almost 1,500 bones, 12 skulls, 20 mandibles. There's, once again, a 1.5-year-old, so we think it was probably a fall season to that kill. There were 3 different unique deposits on the slope below the modern cliff. Again, there was damage from a canid, whether it was a wolf or a dog, we can't say. 23 cut marks. There were skulls that were pretty well beaten up, potentially smashed to get at the brains. We found some microdebitage in situ with the bone remains, and then a few stone tools in situ directly associated with those bones in a couple other places. No projectile points directly associated with bison bones, just the tools that they used to cut them up. Here's a couple of relatively intact bison skulls that we got out of kill 3. Right here is the entire right forelimb of a bison on the slope, from the toes all the way to the scapula, right here, articulated, right? Which is cool. A little diversion here. This is the distribution of known late archaic piscat, right? These are late archaic mass bison kill sites that are known in the Texas and Oklahoma Panhandle region. And you can see, this is a heat map. The densest place is right here at the headwaters of the Red River, near Caprock Canyon in Palo Duro. And here's another way of looking at that landscape and thinking about how bison and people were moving across it. This is looking to the west, right? We're looking towards New Mexico here in the Panhandle region. Wichita Mountains here, Canadian River, the headwaters of the Red River Valley here. And there's a lot of sites in this region. Yeah, there are some Oklahoma, but there's a lot right here. So Doug Boyd, if you guys know Doug Boyd, he's done a lot of work in the Panhandle. He talks about this as an archaeological region, the Caprock Canyonlands archaeological region, because there would have been freshwater springs, there would have been shelter. This whole environment here between the southern high plains and the rolling plains below would have been kind of like a refugium for animals during various phases of past climate, whether it was exceptionally dry or exceptionally wet. This would have been a good place to live. So it's interesting to think about, like, how people were potentially gathering on this landscape to harvest bison in mass on a seasonal basis. And where were they coming from? Were they living there the whole time? Were the bison living there the whole time? These are the questions that we're trying to answer with some of the chemical analyses that we are doing. All right, Kill 4. Kill 4 is about 900 years ago. We don't actually have any bison remains per se. Kill 4 was a thermal feature that Dr. Chris Lentz here forced me to excavate. I did not want to excavate it. I thought it was melanized dirt. It was, before we dug it up, it just was like a black stain. And I was relatively sure at the time that it was some kind of organic illusion from one of the junipers that was growing on the slope. Anyways, so I gave Chris a crew. I said, "You think it's so great? You go dig it." And so Chris dug it up, and lo and behold, we had a little hearth with a bunch of burned rock. And as work progressed, charcoal started to show up, juniper charcoal that Leslie Bush identified, and then little bits of burned bone, as well as microdebitage. This is 2 millimeters. This is the kind of stuff that gets lost when you screen, right? We found this in our flotation samples. And these bones are curious because we didn't find anything but bison at the site, with the exception of some prairie dogs who came later and chewed up all of the deposits. But this is a small animal, but it's not a small animal. So you can kind of tell by looking at the circumference of these long bone fragments that it probably would have been a mammal that was about cat size. And I can't prove it, but I'm pretty sure that this is a prenate bison. And this is something that people, well documented in the northern plains, they would kill bison ideally in the fall, because that's when females are fattest. That's when females are also pregnant. If you cut them open, you can get those veal-like prenatal bison out. And I showed the dental data on the teeth to Dr. Lee Bennett in Oklahoma, and one of the first things he said to me is, there aren't any prenates. There aren't any critters from this particular age group. And so the question was, where are they? People ate them. That's what I think. So yeah, there are things that we could do. We could do ZooMS, mass spectrometry, do some biomolecular analyses of these bones to say that they probably are bison. I'm pretty sure it's bison. That's my just so story. It's the right size. So probably this was a snack station, right? People just were butchering bison and said, let's cook a fetus real quick. And that's what they did. The first time I came across this behavior, I'd already been working on bison at Nighthawk for a couple of years. I went to the Royal Museum in Toronto, and they had a water bladder made out of a bison fetus there. Oh my God. So this is like something that was an integral part of bison people culture, was eating fetuses, using those bison fetuses for different things. So it's not a far stretch at all. All right, so that's kill 4, bison fetus. Kill 5 was all the way up here. It wasn't all that interesting, other than it was basically the butt end of a bison that some juniper roots had grown through. But spatially unique, temporally unique. It's got this radiocarbon date that none of the other bones have. Kill 6 was around a gully, and that was one of the units that Texas Tech started, and then we expanded it later in our subsequent dig. And one of the interesting things that we found there initially, other than this really pretty Washita point, was we had this fragmented humerus with this longitudinal spall on the shaft, suggestive of blunt force trauma, potentially trauma related to what scientists would call a vertical deceleration. This is what the literature says, right? As many bison jumps as there are, 200-300 bison jumps in the country, including Canada, hardly anybody's documenting this kind of perimortem trauma that actually happens to the bones when the bison hit the ground. And so there's no good literature to draw upon to compare this to. This does not look like a typical fracture that you would see if somebody, say, grabbed a rock and broke open that bone to try to get the marrow out. This is totally different. So that's my story on that. The other interesting thing about Kill 6 was it wasn't very dense, and a lot of the bones were gnawed. What you're looking at here are gnaw marks from prairie dogs. The prairie dogs had invaded this component of the site. We found like 3 prairie dog skulls in this and lots of gnawed up bison bones. And we actually dated one of the prairie dogs. They came in around 200 years ago and occupied the site. So I tell people, Nighthawk is cool because we have both of the charismatic mammals that live in the park or at the site. Prairie dogs and the bison right there. And so, yeah, we found 2 of these Washita arrow points in that vicinity. I think people may have taken some shots at the bison before they went off the cliff, which would explain why they're there. Finally, Kill 7. 400 calibrated years before present. That is very late. This individual was way over here. It was one subadult bison, the hind limbs of a subadult. So you can see that the toe bones are not fused. It's post Antelope Creek. And we can't say with much precision exactly how old these bones are because the radiocarbon calibration curve is really wonky right there. So it's around the time of the Coronado expedition, which I think is pretty cool because Coronado went into that neck of the woods. They interacted with bison hunters, right? But they never, as far as we know, saw people chase bison off cliffs. So it's an interesting question. It's like, who did this at this particular point in time? Who was still jumping bison in that region? Because the Apache moved into the Panhandle around that time and presumably displaced Antelope Creek people and other Plains Village people that were living in the region. So the simplest explanation would be the people who had been jumping bison there for thousands of years were the ones that did it, but potentially the newcomers could also have started to jump bison in this place. All right, so here's another look at the site that maybe sort of better explains what I'm talking about in terms of the jump off locations. The cliff used to be here. Now it's here. And even over here, you can see that the cliff has receded almost 15 meters since those deposits formed. So it's an ongoing process. The site is slowly disappearing. All right, how does Nighthawk fit into the known record of jump hunting in North America? A little graph. Here's Bonfire, Bone Bed 2 at Bonfire, which is the Paleo-Indian. Butternut Creek is a site in Kansas that hasn't been studied very well. This is Head Smashed In. Head Smashed In Bison Jump in Alberta, Canada. If you ever get up there, really cool place. Most conservative archaeologists think of this as the oldest bison jump in North America because they don't like Bonfire. And bison jumping started at Head Smashed In the Middle Archaic. And then there was this hiatus, and then bison jumping started again in the late Archaic. Here's Nighthawk. Nighthawk kill 1, Nighthawk kill 2. You can see it's back here in the late Archaic with some of the older components. And the interesting thing, if you look at the big picture of bison jumping, is prior to about 2,000 years ago, you have just a handful of bison jumps. After 2,000 years ago, you see this novel culture develop in the northern plains where everybody's doing it. Some archaeologists refer to it as classic bison jumping or bison industrialization, right? So people are harvesting just massive numbers of bison. Most of the bison jump record that we know that sets the standard for which we judge other bison jump sites is this classic thing, this weird classic thing that happened within the last 2,000 years. That is not fair to judge things that are prior to the late prehistoric period. So I take issue with what Byerly et al. Did when they said, hey, bonfire shelter isn't real because here are all the classic bison jumps up here, bonfires down here. Bonfire doesn't have a drive lane that's marked by rocks. Well, we don't know, whether that was something that people were doing prior to the late prehistoric. Classic bison jumps are different, so we can't judge these older jumps from the later developments. There were only a few jumps prior to 2,000 years ago, and only a few have dates. And, you turn it on its head, Texas actually has more pre-classic bison jumps than people in the northern plains. And the other problem, of course, is the work that happened on most of these sites, they did not directly date bison bone. They have projectile points that they think they know how old they are based on those projectile points. So, there's a lot of work that could be done going back and looking at these bison jumps and actually directly dating the bone. Here's a figure that we actually published in American Antiquity. Here's your classic bison jump area. Basically, it's just Wyoming, Montana, and southern Alberta. Yeah, there's one jump in northern Colorado. And George Frisson, who basically was the dean of bison hunting archaeology at the University of Wyoming, he would say that you could stand at this Roberts jump in northern Colorado and look north and just see a string of bison jumps, one after the other, after the other, after the other. These are the classic jumps that started after 2,000 years ago. In the south here, we have Bonfire Shelter, we have Nighthawk, we have the certain site in Oklahoma, and this Burton Wood Creek site. There aren't very many bison jumps prior to 2,000 years ago. We look at the radiocarbon data. Here's Head Smashed In over here. This is the oldest calibrated dates from Head Smashed In. So they were jumping in the Middle Archaic around 6,000 years ago. You have this 2,000-year hiatus at Head Smashed In, and then people start jumping again. But they start jumping again at Head Smashed In at about the same time as the earliest stuff at Nighthawk. So basically it looks like people are simultaneously starting to do bison jumps in the northern plains and the southern plains at almost exactly the same time, which I think is pretty cool. I don't know that that's necessarily real. It's probably, an artifact of us not having enough direct dates on bison bones. The other interesting thing about the radiocarbon data is we can look at the duration and frequency of use of it as a hunting installation, right? Here's Bonfire, right? We have that really old component, Bone Bed 2, relatively young component in the late Archaic. Head Smashed In, you have Middle Archaic use, and then from about 3,000 years ago all the way up to the historic period, they were using it again and again and again. But we don't have that resolution because archaeologists don't have the mojo to go in there and dig it up. There's so much bison bone there that it would take, centuries to actually analyze. But this is what makes Nighthawk neat is we have actually been able to detect 7 or more unique events. So people are coming back to that place over and over again, despite the fact that the cliff has moved. They're like, this is a good spot. We're going to keep coming back here. That's a big deal. And so that leads to other questions. It's like, okay, if you're using the same place over and over again, you have to invest time in terms of maintaining it. Do you have to defend it against competitors, other groups that might want to use that same hunting facility? There are examples of people doing things like starting wildfires in the northern plains to actually encourage plants to grow, for the bison to come in and graze, right? So if you want to bring bison into your collection basin to drive them over a cliff, you want that grass to be really attractive, right? And so there are examples of people doing that in the northern plains, and that's something that we've started to sort of ask questions about in looking at the broader landscape around the Nighthawk Jump, because this is a challenge. It's not one spot on the landscape. It's a hunting landscape. You can't understand what's inside your excavation unit unless you look at the entire landscape that people were carrying out these activities. So, zoomed way out, here's Nighthawk. This is, you can't even see it, Lake Theo is down here. Lake Theo has a history of people hunting bison that goes back 10, 11,000 years. It's a Paleo-Indian site at Lake Theo. Okay, and so the question really becomes, how did people manipulate bison on this landscape to get them into position to make that jump? And this has all been private land. The park itself, funny story that I didn't include in the slide on, the bison actually jumped into the park. Okay, the property line between the private land and the park is right there. So luckily they jumped into the park and we were able to actually excavate those deposits. But this part of the drive lane complex, of the hunting complex, was on private land. Parks has now acquired it, and we started doing survey and things like that to try to get a better sense of what kind of activities were people doing up there. We do not have those drive lines, those piles of rock that mark, the ideal route for people to get up there. That isn't a big deal because people could have just piled up brush and it just didn't survive. So 3,000 years, one of the important questions here is this spans multiple different phases of culture history that we know about in the Panhandle. We have this late archaic Little Sunday complex. This is a name for a bison hunting toolkit that people utilized in the late archaic. So that spans from kill 1 to kill 3 when the cliff itself moved. Then you have this interval, the Paladura interval, where you don't find a lot of bison in any site in the Panhandle during that period of time. Very little. Lots of deer, lots of things other than bison. And this is a time when archaeologists think that potentially people moved into the region from southern New Mexico, the Mogollon people. And the record at the Nighthawk site respects this. Nobody was using it to jump bison during that interval. And all of a sudden, you have people coming back and using the site again during the Antelope Creek, the Plains Village phase, and then all the way up to kill 7 when you have modern people, Apache people moving in from the north. Who knows what's going on? It's wild, but this is an interesting story, right? It's one hunting facility being used during all of this change through time. I don't have any good answers. I only have guesses right now, but the other interesting thing about it is Nighthawk is the only late prehistoric mass kill site in the state. Okay, we know that people were hunting bison quite a bit in the late prehistoric. Perdiz points, Scourin points are very commonly found in association with bison bones, but not massive numbers of bison bones in one place on the landscape. Okay, so that's a pretty interesting thing about Nighthawk. And beyond Nighthawk, once we got out into this landscape, we began to realize, actually, it's not the only one. There are many other jumps that have been identified, and there are many jumps that are yet to be found at Caprock Canyons and in the vicinity. And so when Chris went out and surveyed the area, he found a really nice serrated dark point right around here And we were really interested in this landform because, hey, this is another spur from this platform that juts out into the valley, very much like Nighthawk. We eventually found some bison bone right there. Not much. We got it dated. It was a 600-year-old bison bone. So all of these other little spurs jutting out into the Canyonland region could have served as potential drive lines in the past. And the other interesting thing about this, as compared to every other bison jump in the Northern Plains, is the scarp is not parallel. When you think about bison jumps, you think about people driving animals to a perpendicular cliff, right? That's not what's happening here. I tell people the type of bison hunting, the type of bison jumping that was being utilized, it's more like walking the plank than scaring them over a cliff, because they saw it coming. Okay, those animals knew that there was a fall, and somehow people got them to fall anyhow, which is very curious. I threw this in here just to give you a sense of how bad the tyranny of preservation could be. This little tortellini-looking bone here, that's a petrous bone. Okay, inner ear bone. It's one of the densest bones. It's one of the most likely to survive in bad situations. And the space between these two known sites, there's just one little bone. There could have been thousands of bison bones, skeletons, laying on this landscape for the past 3,000 years, and we wouldn't have any idea about it. You know, very likely that's the case. There are many jumps in the Northern Plains where they have absolutely no bone deposits. The only reason that they know that there are bison jumps there is because they have those cairns marking the drive lines leading up to the cliffs. Okay, so you have to use your imagination a little bit to appreciate the fact that we had anything preserved at all, that we were able to learn something from it, and then sort of open your mind to the possibilities of what we're missing. And here I am. This was in the spring. We went and, for a long time I had been thinking, okay, here's the jump. It's at a particular contour. What if we just follow this all the way around to the northern edge of the park? And lo and behold, in the same topographic position, we found a bone bed on a slope below a cliff. We dated this to about 800 calibrated years. It's, I think, almost exactly the same as our Kill 5. And this site was known. This site had been described by Texas Parks and Wildlife as a lithic scatter. They were looking down at their feet for stone points. They did not know, hey, I should look up at this slope to look for bone. This is a bison humerus. This is part of a rib cage in situ. This is the site from a different angle. Here's the slope. There are bones throughout right here. There are bones all along here. There's a gully. There are bones all along here. It's almost exactly the same as Nighthawk, just a little bit smaller. These are a couple of Mescalero Apache fellows who were out there with us. We were doing some tribal consultation. And I thought this was cool because, it's probably the first time that Native Americans have been present when a new bison jump was actually found. And then there are other bison jumps. So there are 8 scientifically confirmed bison jumps in the park and the adjoining land. So there are now 11 jumps in all of the southern plains. 5 years ago, there was basically 1. Nobody was asking these questions. The interesting thing here is in the 1970s, Texas Parks and Wildlife did a survey of this private land. This is to the northeast of Caprock Canyon State Park. There were 4 bison jumps that were described in the literature. Nobody bothered to go back out there. Come on! There was only 1 bison jump in Texas up to that point. Nobody bothered to go. I mean, even the park's archaeologist that is in charge of this park didn't know or didn't care enough to try to get somebody to go study it. So I've still been trying to get in touch with these landowners to get permission to go out there and just sample them, because I just want to date them, I just want to know how old they are. There's another jump very close to the visitor center at Caprock Canyon State Park on Holmes Creek. that we finally dated, and there's nothing left. It's like the deposit. If we were to go out and excavate it, we'd have 2 cubes of deposit. We got a date, and it came back to 18th century. What? We're like, we need to go back out with a metal detector. Okay? I mean, the idea that people were still jumping bison that late is wild. So it's like we have so much to learn about how people were doing communal bison hunting in this part of Texas. So, all right, there are at least 7. There are probably 9 or more kill events represented at Nighthawk over 3,000 years. The timing and number of those use events is extraordinary in all of the plains. Site record is very biased by erosion. There are lots of events that are limited to just a few bones. The late archaic to proto-historic to historic now, people in the area killed bison using a jump technique often in this area. Not like, hey, Southern Plains people couldn't stampede bison over cliffs. They didn't have any reason to. No, they did. And bison hunting isn't a blasé topic. It's not in vogue today to do much work with bison, as charismatic as bison are. It was a thing that people did in the 70s. Nobody wants to excavate these sites anymore because it's a lot of work to go through, clean all those bison bones. But there's so much we can learn, at least if we just do specialized, chemical analysis, radiocarbon analysis of these. So thanks for your time, and I'm ready to answer questions. Yeah, Francois.
Okay, so what are the chances that a bison didn't die on its way down, and maybe those watchtower points were there to finish the kill?
Okay, so Francois asked, does this still work? Yeah. What are the chances that a bison fell off the cliff and didn't die, and the watchtower arrow points were used to kill the animal after
It fell.
Good. I don't see why not. That particular bone bed was so scant that we couldn't really develop like a good story as to whether or not we can't reject it. That idea. Yeah. So.
Is there any evidence in any of these other sites that what you're finding at the bottom is basically the end of the bison story alive, that that any of them would survive and did get finished off down there? Is that a question that anybody would want to ask?
So I think what you're getting at is, are the bison potentially at the bottom of the pile just what was left behind?
Yeah.
Yeah, 100%. So most of what we probably found was the waste material. You imagine a pile of 100 bison, you're not going to be able to make use of all of them, especially if you don't get them skinned quick because they're big, beefy animals. They're going to spoil fast. Imagine, any of you who are deer hunters leaving an animal out in warm fall, potentially weather. If you don't dress them fast, they're gonna spoil. And so those animals that were collected probably were the animals that were at the bottom of the pile that we collected, which is why we didn't have a lot of evidence of butchery.
Right.
So,
Thank you.
yes.
I was wondering if something associated with what Gus was saying. Those points were found down at the bottom of the drop, not any up above. Is that true?
Yes, the points that we recovered were on the surface that the bison would have hit after falling.
Okay. But you mentioned, I thought, that they might have been fired as pot shots up above.
Yeah, in the case of the arrow points, because they were directly associated with the bone bed itself, it's certainly possible that those animals had arrow points in them when they fell off of the cliff.
The reason I asked that is I was thinking probably not every bison had high IQ. But if there were some who did, and they could see a long distance and they knew something bad was coming up, they might have balked. So could they have been encouraged to speed it up a little by those points?
Yeah, I think that absolutely is my thinking. When you look into the literature on like how people think these these bison drives towards cliffs work. The landscape at Nighthawk does not fit into that at all because they can see it coming. There's a lot of focus in the Northern Plains on optical illusions, getting the herd to turn at the last second so they don't actually see the fall, tricking the animals, essentially, because all forms of mass bison kills rely on tricking the animals. If they can see what's coming, it's harder to control what they're doing. So I don't know exactly how it worked. All I know is it worked because we have deposits, 7 or more, over 3,000 years. There was something about that place that people kept coming back to. I don't have to explain it. I can come up with lots of weird ideas, but somehow they made it work. And it goes against all, common knowledge about how these bison jumps work, really, is that they could see this fall coming. And you walk that area over and over again, you're just like, how did they manage to get bison to come down here? It's bizarre, but I know that they did because they couldn't get up there from down below. They just couldn't. Yes, sir.
Thank you for your presentation. It was very informative. How did you leverage new geophys technology like LiDAR, ground penetrating radar, resistivity, such like that?
Yeah, good question. We had a guy named Mark Willis come out, and he's a great archaeologist who does a lot of remote sensing work. He has a drone with a LiDAR sensor on it. He flew over the site, and he was able to gather data that we were able to make these really nice digital terrain models with. And during actually prior to our fieldwork in 2024, we had a magnetometer survey done in what we were calling the processing area over here, because we figured, yes, there's a lot of burned rock in this region, so we presumed that a bunch of cooking was going to happen. And so one of the things that we really wanted to get, that they have at other nice bison jumps, is cooking features with bison bones in them that are intact. Those would be the most valuable thing to find. Finding a bunch of bison bones, probably which were the ones that got left behind, that weren't eaten, is less useful in terms of reconstructing human activities and behavior than finding cooking refuse near the site. We found a couple of those features with burned rock in them that were intact, but there wasn't much there to learn from. And this area is still intact. It's not as endangered as what's over here. So one of my hopes really is that somebody follows up on the work that we did. We found a few magnetic anomalies that we thought potentially could be consistent with some kind of thermal feature where people were cooking bison. We shovel tested those areas and we never really found anything very compelling. So I don't know. I hope somebody someday will go back and try to learn something more about that, because that would be very informative if we were to be able to find a feature like that.
Follow-up question. Using an erosion model, could you figure out what the geology looked like going back in time?
Yeah. If we make a lot of assumptions about the rate of erosion, yeah. And Charles Frederick wanted me to project out where the cliff was even before 3,000 years ago, because actually there's a little mesa here. So the first jump that we know about was right here, but you can see that vestigial spur extended further out. There's nothing left here. It's eroded down to bedrock. But in theory, there could have been even older deposits right here. And yeah, so we can do that math and come up with projections. And people have done that all the way back to the early Pleistocene. The Caprock itself of the Southern High Plains has been receding at different rates through time. And so we can actually say, well, the erosion front of the actual escarpment was way out where the rolling plains are today, because we actually have deposits from that time. So yeah, we can play that game. I don't really feel like we should, because it gets very speculative, because the way that this environment erodes is not constant. It just sits there, and then you get a rain and just things change really rapidly. Yeah.
What was the time period from the bison gathering in the pasture and then being driven down the driveway and then the jump and the processing? What kind of time are we talking about?
Right. So the question was, what kind of time frame did the hunting event actually play out across? We don't know, is the answer. We can make guesses based on ethnohistorical accounts from the northern plains, where we're entirely reliant on what people were doing in the northern plains that Europeans describe. And one of the things that I didn't tell you was no European has actually ever seen a bison jump happen. We have our Charles. We have the painting, right, that makes it look like, where is it? There it is. Who is this? Charles Russell. Thank you. Yeah, love this painting. He never saw that. This is just guesswork.
The horses doing it.
Well, that's it. Okay. The only eyewitness account of a bison jump was watching Indians try to do it on horseback, which is not how bison jumping worked. And they weren't very successful in trying to do it. Horses are not, once you have a horse, you don't need the bison jump. You can cherry pick those bison just by running them down. So once the horse showed up, people stopped hunting bison this way. In the northern plains, the Blackfoot called the bison hunting days are often known as the dog days because they used dog travois to move their teepees and all their materials around. That's when they had dogs. Horse days, they stopped hunting bison using jumps. So, and that's one of the interesting things about bison hunting, bison jumping in the southern plains is we have no ethnohistoric analogs to use. The Apache have no recollection of hunting bison this way. The Comanche never hunted bison this way, probably. Although that one site I told you about that's in the 1800s could be something like that. So, Chris.
Could you go back to that slide you just had a moment ago, the two drive?
The two drive?
I think that's what you had.
What? Can you describe it to me?
I think that may be that right there. And it was the one that had the plateau.
Oh, right.
The orange plateau.
There it is.
Okay, my comment is, at this point in time, it looks like we don't have drive lanes necessarily coming identified, associated, leading animals out to the spur. However, in the upper left side is the erosion of Holmes Creek. And you see that's a fairly gentle slope relative to other escarpments out in that area. I just want to comment that the plateau that you got listed there has been farmed by Ronnie Carpenter for about 40 years. So if they were drive lane dead men, 3 or 4 rocks in a row, they might have been plowed out of existence.
Yeah.
And the way you want to find it is go into that rough, broken ground, Holmes Creek, and pay attention to that area in great detail, and look for your dead man markers in that area.
Yeah. So Rick Day and I spent some time looking around here. These little gray circles are like places where we found rocks. So part of the problem here is this is not clear. There's juniper, there's grass, there's all kinds of crap that you don't, like in the northern plains where you find drive lanes, it's pretty well open. It's not all scrubby like this. So if there was stuff there, we wouldn't see it. Even with the LiDAR survey, you can't find an individual stone laying on the ground or a couple of stones with LiDAR. We've tried. We were hoping to get more LiDAR survey data to see, but I don't think there's currently anything. In the past, yes, maybe there could have been. This area was plowed. Texas Parks and Wildlife, because they just acquired this land, they're going to do a survey. They're going to put a contract out for people to survey it. I'm not hopeful. There's just stuff everywhere up here, like especially on the edges. of. It looks like people were camping up there, but the problem is 3,000 years. You have superimposition of different activities in this region.
And especially the Tacoma shirt deposit.
Yeah, right here. There's a big mountain of toolstone just sitting there.
That's one of the biggest ones I'm aware of.
Yeah, and it's all over. So, yes, sir.
You showed a timeline at the end of your presentation over the Holocene, and you showed some gaps.
This one?
Yeah, that'll work. So you've got gaps in there of a few hundred years. Is there any geoarc evidence that would tell you maybe there's a bit of a change in climate such that either the bison didn't come there because it went around, or the people didn't come there, or both?
Yeah, there is data where I could try to develop a story one way or the other. I don't trust any of it. It's like you look at what we call proxy data, right? You can look at pollen from Oklahoma. Chris worked on a site in Oklahoma where they found, fossil trees around 3,000 years ago, and you could develop a story about what the climate would have been like. But this is a unique environment. Okay, so I'm not sure that the immediate vicinity behaved in a way where proxy climate data from Oklahoma or the Carlsbad Cavern flowstone deposits and things like that would actually be able to tell us exactly what was going on there. Now, the bison themselves can tell us a little bit about what the climate was like, and I have isotope data on their teeth, which I can use to try to develop a story about that. But we're not there yet. Is the short of it. Yeah. But very likely what we're seeing here is some kind of period where it was really arid. And so the site, it looks like overall, during the first 3 kill events, it was relatively wet. And then in the style of deposition actually changed. So we have really large colluvial slope deposits, these little aprons of dirt that form below the cliff from kill 1 to kill 3. After that, we end up with these little rocky patches of dirt that form at the base of the cliffs. And so you have these really small deposits of bone that aren't very well preserved. And it's patchy. You're lucky to get buried and preserved in those situations. So, yes, sir.
You were talking about how the length of the drive eroded over the years and it shrunk back. What about the width?
Yeah.
Did it erode also?
And once again, you got to kind of use your imagination. It's like we look at this as a hunting landscape today. I don't know that any of this was here. This big gully, it probably wasn't. This thing could have been way out here. This cliff edge here probably is worn back quite a bit. Looking at the literature for the watershed itself down here, the drainage density of this basin is one of the highest drainage densities in the country or in North America. And drainage density tells you, hey, there's a lot of erosion happening here. Okay. A lot of little tendrils cutting up into this escarpment that are sucking dirt. And the other thing about this that I didn't even mention is there are salt domes in this basin below that are mapped. There are salt domes that they've blobbed up from the subsurface below because salt's buoyant. And then once they intersect with the water table, that salt dissolves and you end up with a collapsed basin. And those collapsing basins are hungry for dirt. Okay. And that accelerates erosion even further. So it's just like miraculous that any site like this is preserved in this landscape. And there was a guy in Oklahoma that wrote a paper in the 90s that the title was "Where's the Cliff?" And he basically said that there were never people using bison jumps in the southern plains because there are not cliffs. Like, well, you work in Oklahoma on the rolling plain, there probably aren't very many cliffs, but the Caprock escarpment, the southern high plains, is bound by big-ass cliffs. That's what it is. Now, to be fair, the entire length of the escarpment from bottom to top, you wouldn't want to run a bison off of a drop that's 100 feet, right? You go to Paladuro Canyon, you see how deep that is. You wouldn't run if you run a bison off that, you're going to end up with hamburger, right? I mean, and when people who hunt deer, probably familiar with the gunshot, right? How the meat of the deer is bruised around where the projectile hits the deer. You usually cut that out, right? Because it's not good. Well, there's an ideal Goldilocks zone for how high you want that bison to fall. It has to be more than 10 meters, so it kills them, but it needs to be less than 30 meters. And that is true for all 200 to 300 bison jumps that are known. They are not too high and they are not too low. So that's pretty cool, I think. Yep. Oh, one more question. There you go.
Your earliest date was 10,000 years?
No, not at Nighthawk. There was a site nearby that wasn't a jump. The Lake Theo Paleo-Indian site. That's about 10,000 years old. There's a Folsom and Plainview component.
Have you ever found the buffalo commingled with the mammoth or mastodon?
There are sites like that. Usually they're like lakeside sites like Lubbock Lake, where bison and mammoth might have been in the same place and died. But in terms of actually people actively hunting them, no.
Well, back in the 60s, I've been doing this since I was 6 years old, but we found a cliff in DeWitt County and a mastodon, or it was a mammoth. We had the bones identified and dated by the university, but the entire mammoth was there.
Mm-hmm.
The tusk, etc., and it was at a base of about a 30-foot cliff.
Yeah.
And I'm wondering if that because this is in DeWitt County,
Mm-hmm.
South Central Texas. So I have always been curious if that was a kill jump.
Yeah. Yeah, you have to, when you find animals in situations like that, you have to be a little bit skeptical, especially when there's no precedent for it. Now, there's a site in the United Kingdom on an island, on Jersey Island in the British Channel called La Côte de Saint-Brelade. And that site from the 60s through maybe the 80s, people thought they had evidence of Middle Pleistocene proboscidean drives, right? So people were driving elephants off a cliff, and this was more than 100,000 years ago. These were basically Neanderthals doing this. And for a long time, that's what people thought was happening. And, modern taphonomists have come in, re-examined those bones, and come up with a different explanation, like the bones were getting washed in by waves or something like this. So there's no examples of people stampeding anything bigger than a bison over a cliff that I know of that has stood up to scrutiny.
Right.
It could have happened, it could have happened on a fluke, right? Or maybe it happened relatively often, but it didn't happen enough that there's a very clear cultural signature like there is with bison jumping in North America. So, all right. Thanks for your time, everybody.